Hey everyone, if you've ever actually felt the ground shake or even just watched the crazy aftermath on the news, earthquakes can feel like these totally random, terrifying mysteries, right? It's so easy to just write them off as unpredictable acts of nature. But in today's explainer, we're going to build a really clear, logical mental model of the fascinating chain reaction behind them. By the end of this, you won't just know what an earthquake is, you'll absolutely understand the elegant and, yeah, super powerful physical system that makes the ground move. So why did they suddenly strike? It's a question we've literally all asked when the ground starts to rumble. Why does this huge, terrifying event seem to happen completely out of nowhere? I mean, it feels like the Earth is just sitting perfectly still, minding its own business, and then, bam, it violently decides to shake. But as we're going to see today, that suddenness is actually just the very end of a much, much longer story. We kind of hold on to this illusion of random violence, don't we? That an earthquake is just the planet suddenly getting angry. Well, the reality is way more scientific and, honestly, a whole lot more interesting. It's a sudden release of long-built stress. It's really just the ground's way of finally letting go of this immense energy it's been quietly hoarding for years. To really wrap our heads around this reality, we have to look deep beneath our feet. So let's jump into Section 1, Hidden Forces Inside Earth. Okay, first things first, the Earth we live on, it's not a single, solid, smooth shell. The crust is actually a massive jigsaw puzzle of rocky plates. Deep inside, there's still intense heat left over from when the planet formed, and this heat drives a ridiculously slow circulation of material. Think of it like thick soup slowly bubbling in a heated pot. As that deeper, hotter material moves, it literally drags these giant rocky outer plates along with it, 24/7. But here's where things get tricky. Those massive rocky plates don't just glide past each other. I mean, if rocks acted like smooth ice, the stress would just slip right away. But they don't. Rock surfaces are incredibly rough. They're full of tiny bumps and fractures. So when one plate tries to move past another, their edges catch and they lock together, almost exactly like rough Velcro. The plates themselves are still trying to move, but the rock edges fiercely resist. And that brings us to the core physics of the whole thing. Because the plates are constantly moving, but the edges are totally locked, the rocks actually start to deform. They bend, they twist, they stretch. This stores up a massive amount of energy, which scientists call elastic strain. The rock isn't soft like clay, it's completely rigid, but it's slowly being loaded with an unbelievable amount of physical pressure. To picture this, just think about a stretched rubber band. Or actually, think about yanking on a jammed drawer that's stuck in its frame. You know how the force builds quietly in your arm until it suddenly just jerks open? Or think of bending a plastic ruler. The tension just builds and builds, waiting to snap. The Earth's crust is doing the exact same thing. But instead of a plastic ruler, we're talking about millions of tons of solid rock storing up mind-boggling amounts of energy over centuries. So if you put it all together, this entire hidden process is a totally logical system. Deep heat drives the plates, the moving plates create stress, the rough rock edges resist that motion, causing stress to build, and that stress heavily concentrates at weak points called faults. And then, when the rock just can't take it anymore, a sudden slip produces the earthquake, releasing all that stored energy. It's a continuous, unbreakable chain of cause and effect. Which brings us right to the exact moment of truth in Section 2, Turning Stress into Waves. We know the energy is locked underground, but when the fault finally gives way, a lot of people think the whole thing just snaps all at once. Actually, scratch that. That's a huge misconception. The fault is messy. Failure actually starts at one specific little patch that just can't hold on anymore, and then it spreads. It's exactly like peeling apart two stubborn pieces of tape. One small section lifts, transfers the force to the next section, which then gives way, and the tear just unzips violently along the fault line. As that moving tear happens, it unleashes all that stored elastic energy. But the energy doesn't just sit there. It ripples outward through the solid rock, much like dropping a heavy boulder into a totally still pond. The fault slipping is just the trigger. The waves are the energy carrying that release outward, sometimes traveling faster than the speed of sound through the solid rock. And the shaking you feel up top, that is literally just the physical passing of those massive waves through the ground right beneath your feet. Now, this energy actually builds into three distinct types of waves. First, you have compressional motion, which violently pushes and pulls. Second, shearing motion, which aggressively moves the ground side to side. And third, surface waves, which travel right along the top layers of the crust, kind of like rolling ocean ripples. And these are usually the ones that do the absolute most catastrophic damage to our cities. For example, take a look at compressional motion. When this wave passes through, it pushes and pulls the ground back and forth in the exact direction the wave is moving. It behaves incredibly and destructively, like a metal slinky being rapidly squeezed and stretched. The motion doesn't just stay where it started, it travels forcefully outward, taking the energy right along with it. Now here is a real game changer. The ground itself plays a massive role in what you actually feel. As these waves travel up to the surface, they pass through different rock and soil layers, meaning two towns right next door to each other can have a totally different earthquake experience. If your city is built on a soft, ancient, dry lake bed, that loose soil acts like a bowl of jelly, wildly amplifying the shaking. But a neighboring town on solid bedrock, they'll feel it faster, but with way less destructive sway. The ground is literally shaping the waves as they arrive. And because these different waves travel at completely different speeds, the shaking evolves over a few terrifying seconds. The very first waves to hit might be smaller and faster, like a warning rumble. Then, the later waves crash in, carrying the really heavy, damaging motion. The whole pattern travels through the earth like a massive, unstoppable stadium wave, starting in one section and sweeping intensely through the landscape. Okay, so we've tracked this from the stuck fault all the way up to the shaking ground. Let's look at the entire lifespan in Section 3, the chain reaction unveiled. This timeline right here beautifully ties our whole mental model together. For decades, plates move and stress quietly builds up. For years, the fault locks, and that elastic strain increases, tightening like a giant spring. And then, in just a matter of fleeting seconds, the fault slips, the rupture violently spreads, and those waves radiate outward. An earthquake isn't a sudden mystery at all. It's literally a decades-long buildup that simply finishes in a few terrifying seconds. Which brings us to our main empowering takeaway. Earthquakes are what happen when slow-moving Earth stores too much stress, then releases it suddenly through a fault, sending waves through the ground. It's just the ground letting go of pressure. With this model in our heads, we don't have to view the shaking as an angry, random attack from nature anymore. It's the completely predictable, highly logical physical release of a planetary spring. So the final thought I want to leave you with in this explainer is this. If we can cross this gap from seeing earthquakes as random mysteries to understanding them as a physical chain reaction, what else can we learn? If we can read the logic of the Earth so clearly, how might we one day master these waves and completely protect our future cities? It's a huge puzzle, and we're getting better at solving it every single day. Thanks for exploring the mechanics of our restless planet with me. Keep asking great questions.